afternoon. Good afternoon. We're going to wait just a couple of minutes as participants enter.
Okay, I think our numbers might be stabilizing. So if we're ready to get started, I think we can begin.
Okay. Thank you for joining us. My name is Deirdre Henderson, and I'm the co-leader of the North Tahoe Chapter of Citizens Climate Lobby and Citizens Climate Education, and I'll be one of your co-hosts today. Citizens Climate Lobby and its affiliate, Citizens Climate Education, is a national, nonprofit, nonpartisan organization dedicated to empowering citizens to advocate and build political will for national climate solutions. We were one of several organizations that worked very hard to get the climate provisions of the Inflation Reduction Act passed in Congress in 2022. And now we are working very hard on spreading the word about funding, pollution reduction, and climate benefits of the IRA in our communities. Today's webinar is the first in a series on how to electrify buildings in Truckee, Tahoe. The series is a collaboration among the Climate Transformation Alliance, 100% Renewable Truckee, and the North Tahoe Chapter of Citizens Climate Lobby. It's designed for us to meet experts from around the country who can increase our knowledge in three areas that we believe are really important for enabling building electrification and decarbonization in Truckee, Tahoe: thermal energy networks, financing and implementation strategies for electrification, and the pressing need for a one-stop shop to simplify the electrification process for homeowners and businesses. I'd like now to introduce one of our other co-hosts, Kaylee Reynolds from the Climate Transformation Alliance.
Thanks, Deirdre. Hi, everyone. I'm Kaylee Reynolds, and I manage the Climate Transformation Alliance, hosted by Sierra Business Council. Climate Transformation Alliance, also known as CTA, is a coalition working to advance climate adaptation and mitigation through collaboration and information sharing in the Truckee and North Lake Tahoe region. We do this by exploring a wide range of strategies to achieve greenhouse gas emission reductions by partnering with public agencies, community organizations, the private sector, and the public. And CTA is always open to new members, so we encourage you to reach out and get involved if you're interested in greenhouse gas emission reductions in our region. Our next in-person meeting will be July 12th at the Truckee Tahoe Airport, and these meetings are open to the public. You can visit our website to learn more about joining us, and we look forward to connecting with you. I will pass it over to Matt Tucker of 100% Renewable Truckee.
Thanks, Kaylee. I'm Matt Tucker, co-lead of the local grassroots climate action organization, 100% Renewable Truckee. Our mission is to ensure Truckee is equitably net zero by 2050 by working with Truckee's varied stakeholders to find solutions that quickly scale up to get us where we need to be, when we need to be, in a way that leaves no one behind. And as Kaylee mentioned about her organization, we're also open to new members and always looking for people who want to help out in any way that they can. Thank you so much. And now I pass it back to Deidre.
Thanks, Matt. So we are very grateful today to have with us one of the most knowledgeable people in the country on thermal energy networks, Ania Camargo. Ania is the Thermal Energy Network Senior Manager at the Building Decarbonization Coalition. She's a 10-year veteran of the movement to spread this stable, mature technology as a heating and cooling alternative to natural gas. She started down this road with her concern as a citizen about leaky gas pipes in Massachusetts, where she lives. She is the board chair of HEAT, Home Energy Efficiency Team, which is a highly respected organization that has pioneered working with gas utilities to initiate networked thermal pilot projects to demonstrate the viability of this technology as a utility scale alternative to natural gas. She's a graduate of Stanford and the Harvard Business School. Welcome, Ania.
Ania, I think you're on mute.
Sorry, I'm trying to do the share screen thing. Here we go. All right. Thank you all so much for the opportunity to come and talk with you. So as Deirdre said, I'm Ania Camargo from the Building Decarbonization Coalition. And as the name implies, we are a national nonprofit that works with all stakeholders to decarbonize buildings. We also work very closely with HEAT, and they're the nonprofit that came up with this idea of doing thermal networks at scale with utility companies. And I am using several of their slides today, so a big thanks to them. So I just want to say I have 3 goals, maybe 4 goals for today. The first one is that you understand sort of why neighborhood scale decarbonization is so important. I know the title of this series is buildings, but I want to say that neighborhoods is really what we're going for. I'd like you all to know the basics of how thermal energy networks work and why they're a good idea. And I'd like to have you leave with a sense of what's happening nationally and in California. I guess my 4th goal is that you are really, really interested and want to learn more, and you want to learn these organizations, join these organizations in the Truckee and Tahoe area. So very big picture, why neighborhood scale decarbonization? And so the country is trying to decarbonize. And this map, in this map, the states in green are those who have commitments to reduce emissions by 75% or more. And they also have RPS, or greening the grid, commitments. And as you can see, there are a lot of them. And when people are thinking about reducing emissions, buildings are about 1/3 of our country's emissions. And so people go after buildings. And the biggest source of emissions in buildings is heating. So what is that? What that has meant nationally is that Americans are buying more heat pumps for their homes than ever before, and they're outpacing the sales of gas-powered furnaces. They have done that now for the last 2.5 years. And as you can see from this article, 25 governors that make up the U.S. Climate Alliance, and that includes California, pledged last September to quadruple the number of heat pumps in the U.S. to 20 million. So this is really great news, but heat pumps are terrific. But I think if any of you are trying to electrify your home, you know that these incentives are complicated. Decarbonizing buildings include a lot of actors, tons of decisions and resources, and it becomes a one house at a time or one appliance at a time approach. It's an unmanaged approach, and that can become costly. Lots of things can fall through the cracks. And it is, you can imagine if it's tough for one home, when we multiply that times 110 million buildings that we have to decarbonize, it is concerning. And I would say that one of the biggest concerns that we can illustrate in this beautiful diagram, you can imagine that this is a gas community. Every building here is on gas. And we've convinced them with our great incentives that they should install an air source heat pump. And then they talk to their neighbor, and the neighbor talks to the neighbor, and they're pretty excited because we have really good there's no indoor combustion, and they're pretty comfortable, and they have heating, not only cooling. And so what this means is that fewer and fewer customers, as these people leave randomly, fewer and fewer customers are covering the whole fixed cost of the gas system. And those poor folks are going to be stuck with rapidly increasing bills. The likelihood is the people who are staying on the gas system are the people who are least likely to afford to get off the system, or people who have no power, like renters who can't can't electrify their homes. And so this becomes a huge equity issue and really bad for the folks who are left covering the cost of the whole fixed cost of the gas system. It's also a big problem for the gas utilities because they have a shrinking number of customers paying for the whole system. So to avoid this, we need a coordinated, scaled, and managed transition that can help ensure equity and affordability and can really help speed up this transition and do it massively at a massive pace compared to what we can do now. So this, we are thinking that there are two pathways to do this, and utilities can do this, but also communities can do this. This doesn't only have to be utilities. There are two pathways, really, there's many pathways, but two big picture pathways. And one is that on the left, the electric network, or also called the target electrification, which the idea is that you take a whole neighborhood at a time. You would take away the gas pipe in that neighborhood, and you would change all of the appliances, and it would be at a whole neighborhood scale. That is an approach that is probably more familiar in California right now. And then there's the other approach, which is thermal networks, which is going to be the focus of what we're doing today, what we're talking today. And so I'm going to now transition to, okay, so that's the big picture. What are thermal energy networks? The first question, though, is what is actually thermal energy? And focusing on the word thermal, you might think of the word thermos, something that keeps liquids inside it, hot or cold. Or you might think of thermal clothing, which helps you stay warm. What these words have in common is that they relate to temperature. So thermal is about temperature. And thermal energy has to do with the transfer of thermal energy, maintaining or changing the temperature within a system. So we think of this as like keeping ourselves warm or our buildings warmer or colder. So most people in the US increase the temperature of their spaces by burning fossil fuels, like either in a boiler or a furnace or even a wood fireplace. And burning is one way to increase temperature, but combustion creates emissions. So the big question is, how do we heat our buildings without combustion? And here is the answer, which is energy transfer or sharing of energy. So think about heating up a space as moving heat into that space, and think about cooling a space as moving heat out of that space. So here are some examples to break it down for you. If my hands are cold and I have a friend whose hands are warmer, my friend can warm my hands by transferring some of the heat from her hands to mine. In turn, their hands cool off a little and mine start warming up. So this is the transfer of thermal energy. And me getting warmer and my friend getting cooler, we're both heating and cooling. Another example, so my friend and I are both outside in the cold and we're both shivering. And we hug, we reduce the amount of exposure our bodies have to the cold air and reduce how much heat is leaving our bodies, thereby conserving heat for both of us. This keeps us both warmer by reducing transfer from our bodies out into the environment, and because we're transferring our heat to each other. So what we're talking about today, when we're talking about thermal networks, is how can buildings hug? So I'm going to say that the answer is thermal energy networks, which is really an umbrella term for buildings hugging and transferring energy. And in this diagram, we're very specifically talking about a subset of thermal energy networks called geothermal networks. And basically what this looks like is that instead of having that gas main down the middle of the street with services to each building, we would have a ambient temperature water pipe. And instead of a gas furnace in each building, there would be a ground source or water source heat pump. And that can heat and cool both homes. I mean, all the homes or buildings. And then we have shallow boreholes in the street, or it can also be in parking lots or in a field. And by shallow, we're talking about 100 to 700 feet not very deep. And the reason why we focus on geothermal networks is because this would allow a system to grow over time. We could interconnect neighborhoods like one block at a time, kind of like Lego blocks. So this technology would allow for that. So let's see how that works. You see here, there's a street connected to buildings, and there's the ambient temperature water pipe down the middle. You see a tall building. You'll notice tall buildings. Let's imagine this is a data center. Tall buildings often have a cooling tower on top. It's because they're always trying to keep, like they're rejecting heat. The buildings call it waste heat. They're rejecting heat usually through a cooling tower on the roof. And that heat is just being wasted. So what we're saying is don't waste that heat. When you're rejecting heat, when you're in the cooling mode, just put it back into this loop. And then that heat can be shared with all those houses down the street, kind of like me hugging my friend. When it's really hot, we're not going to want to be hugging or wearing coats. We want to throw all of that energy back into the street and into the pipe, and it can go into the bedrock. And then when it's cold, all that heat that was stored, you can store it in the earth for the whole season. You can bring it back up in the winter. And so the reason why these systems are so efficient is because not only are we transferring energy between buildings, but we're sharing energy with the earth. And you could notice that there's a 55 degrees on the ground symbol there. And that's because the temperature in the ground, not far beneath our feet, is fairly constant. And so depending on where you live, it can be slightly higher or lower. In Massachusetts, it's 55 degrees. And it remains constant throughout the year, unlike your outdoor temperature. So we were talking today before joining this, right now in Boston, it's 93 degrees. And I think in Tahoe, it's kind of cold. So a heat pump has to work really hard when it's hot. An air source heat pump has to work really hard when it's hot or when it's really cold. But these heat pumps are just working with the temperature of the earth all the time. And then just another thing to make a point of here is these heat pumps are inside the buildings, so you do not have to worry in the winter about snowpack. I'm going to make a quick distinction about geothermal, because now that we've talked about geothermal, you all probably have questions like, wait, is geothermal all the same? And really, we use the word geothermal for many different technologies. And I want to distinguish what we're talking about. It is not Iceland, which is what a lot of people ask me. I'm here on the far left, you see a geodistrict. And what that means, district energy typically in this country refers to buildings that are connected, but you have a central plant. The heat pumps are not distributed. It's a central energy plant. It used to be coal, then it was gas, and now there can be some that are geo. And that means that they're digging pretty far into the earth and they're getting hot temperatures to be able to heat that central loop of buildings that are connected. Then there's geopower, and this is the one that goes way down deep into the earth to generate electricity. And then we have geobuildings. I bet you have some in the Tahoe Truckee area, which are individual ground source heat buildings. And this is a great solution, but for the individual, it's a bigger upfront capital cost. And so they are typically not thinking in like a payment in 50 years. It's a more expensive proposition, and it's harder to maybe say we could do that at scale. So what we're talking about is something that has existed in the past, but thought of in a new configuration and in a new way to allow for mass scaling and expansion. And that's sort of the system that I had previously described with a single pipe, just heating and cooling, not electricity, with ground source heat pumps in every building. So anyway, that's how the technology works. Hopefully that was clear. And now we're going to move into like, well, is this a good idea? Well, here we go back to our neighborhood. And so when you electrify a whole neighborhood at a time, you immediately address two of the big concerns, which is one, equity, which is what we talked about, because you're doing the whole neighborhood, everyone has access. And I'll talk about costs a little, but you're spreading the costs across time and across all customers. And then also very importantly, there's no combustion. Again, you're heating with heat transfer and not with combustion. And so this is really good for air quality, and this is really great from an emissions perspective. That's just regardless of whether it's air source or ground source, you're getting these benefits. There are three additional benefits that I want to just get into a little bit more, because they are really important and associated with thermal energy networks. One is the benefits to the grid. The other is the benefits, like the path for gas utilities. And then finally, something that's important in California, which is water savings. So I'm going to focus on the electric grid because I think this is something you all talk about a lot in California. So efficiency really matters. And here, this is a big deal in the Tahoe Truckee area because you all get cold. And so you want to go with the most efficient way to heat and cool your buildings. So in this graph, what you're seeing is the COP, or coefficient of performance. And what that means, that's the left axis. You see that. And what that means, it's a measure on how much energy goes in compared to the amount of energy goes out. So gas is the least efficient, meaning you put in 1 unit of energy and less than 1 unit of energy comes out to produce the heat. With electric baseboard, you put in 1 unit and you get 1 unit of energy out. Air source is much better. It's more than double. And these are annual. So sometimes air source can have COPs of 3 or 4, and the technology is getting better. So, and ground source is even better because of that consistent temperature of the ground. And then network geothermal is the most efficient. And that is because not only are you using the ground, but because our buildings are hugging, as we discussed previously. And a recent study by Excel Energy in Colorado Mesa University showed that the average annual COP was 5.7. But to give you a sense, in the winter, their COP was 8.9, which is just incredibly efficient. So now we're going to talk about why this matters. All right, so this is a very busy, very hard to sort of get instinctually slide, but it's a really important slide. So I'm going to go through it. This is January to December, as you see at the bottom. And what it does, the solid colors are our current US seasonal electricity grid peaks. And it shows all the electricity use, including commercial, industrial, and residential. And so you can see that the highest use is currently in the summer. And that's because of all the air conditioners that people are putting on. And so the electric grid is built out to the peak because we don't want to have blackouts, right? So the electric grid is always built out to that hottest day or that coldest day. The question becomes, if we are going to electrify all our gas and oil and everything that we have, sort of what's going to be the impact on the electric grid? How much are we going to have to build out? And so you can see here that any method is more efficient than combustion. And you can see, like, if you go with resistance heat, you're going to have to more than double the amount of electricity we have now. If you go with air source heat pumps, you're doing a lot better, ground source better. And then you can see the pink line there starts to flatten the grid. And so that is where there's the amount of everything we have to build, transmission, generation, everything associated with electricity would go way down, and that then translates into lower costs for customers. So just to be clear, thermal energy networks are not going to be going in everywhere. We're going to have a combination of all of these as we electrify buildings. Some of it will be air source, ground source, some of it will be network geothermal. But the point is that you want to do it as efficiently as possible to have the least amount of impact on how much you have to build out the electric grid. And I'm going to show this in a different way, which is if we heated everything right now that we have to transition with thermal energy networks, we would still need 4 times the amount of wind generation than we have today. But if you didn't do it efficiently and you did it with resistance heat, then you would actually need 28 times more wind. So we're going to be somewhere in the middle there. But the idea is that we want to be as efficient as possible when we're doing this. All right, so that's, hopefully I beat efficiency into the importance of all of this. Okay, so now we're going to move on to the path for gas utilities. This one is also a big deal. This is a map of Massachusetts. As Deirdre said, I started on gas leaks in Massachusetts. And here, this map shows all of the leak-prone pipe that our utility companies are planning to replace over the next 5 years. And they're planning to replace them with gas. So when you look at the cost of that, actually, if we look at all of the cost of our leak-prone pipe in Massachusetts, it's $34.4 billion of replacement. So the question is, instead of replacing those gas pipes with new gas pipe, how about when we replace them, and if you put in new gas pipe, we're not going to be using it past 2050. We're going to be paying for it past 2050, but we don't want to use it. So how about instead of gas pipes, we put in water pipes, and we do what we're talking about here. So in terms of the next point, the speed and scale, utilities were created to reduce the cost of duplication and to share infrastructure and to share across customers and time. And so with neighborhood scale, and this can happen with both pathways. This is not just a thermal networks, like even if you did air source. Utilities know where their leak-prone pipe is. They know how to decommission pipe. They know who their customers are. They know the energy data of customers. They can streamline processes. They can purchase equipment at scale. They can make it more affordable, speedy, and equitable, which is why utilities are a natural for doing this. And then another big important path is for utility workers. Just like it's a path for the companies, there's a pathway to green jobs for utility workers. Thermal network water pipes are very similar to gas pipes. And so the existing utility workforce can be easily retrained at scale to install and maintain thermal networks. And the same goes for ground source heat pump installation. HVAC technicians can be easily trained to install ground source heat pumps. All right, so now we've got the efficiency and the pathway. Last one, water savings. And this is a really important for all of you. Remember my first data center that was rejecting heat? Most of these tall buildings, if you notice, big buildings, they have these cooling towers on top, and those are, they're rejecting heat into space. And to do that more efficiently, they use millions of gallons of water. And so if you install thermal energy networks, you can see some of, in that diagram, some of our cooling towers have vanished because they no longer have to be there. It's because instead of rejecting the heat into the atmosphere, they're feeding it back into the water pipe and into the ground to be stored for yet later use or to be sent to other buildings. And so there's not a lot of study going on around this, but when you start looking at different projects, people are reporting incredible savings, between 18 and 46% we've been able to find. And there's one project in Toronto right now that is incredible. It saves 220 million gallons of water a year instead of evaporative cooling. And that is the annual use of 2,000 homes. So just to give you a sense of what we're talking about, if we really are either eliminating or reducing the use of these chillers, we can save a ton of water, and we would be using that energy instead of wasting it. All right. So hopefully now you all know what these things are and why they're a good idea. And now I'm going to move into what's happening nationally. And so the first question is, do these things exist? And they do. There are sites actually with this technology all over the country happening. The ones in blue are the utilities that we've talked about. So utility companies are proposing these. The states in green are where there are network geothermal with the technology as we've described it. That has been going on for a long time. The one in Colorado Mesa has been around since 2008. And then there's these 10 feasibility studies. 11 of these are Federal Department of Energy grants, and several will be awarded funds to install these systems probably in the fall. So these have been going on for like over a year, the feasibility studies. And then the blue with orange is just that they are both utility and feasibility studies. So so these are sites, but I wanted to go a little bit deeper into 3 sites to give you an idea of what's happening. So I'm going to start with Whisper Valley in Texas. And this is a plant. It was a community that was built. It's not a renovation, but they planned this community in collaboration with EcoSmart Solutions, and it's just outside of Austin. It's 450 homes, and it's expanding. Their plan is to build like 7,000 homes. And they're all on network geothermal, and they have solar. Many of these houses have solar, and many of these houses have power walls for storage. So the story here is that the winter storm Uri, I don't know if you all remember it, I think it was like 2021. It's referred to by them as the snowpocalypse. And the temperatures dipped really low, and the thermal network temperature of that loop that goes in the street was incredibly stable, while the outside temperatures descended to below 10 degrees. And so in other places, the neighbors of this community, though the water and the gas pipes froze, and then the electric grid went down, and when the temperatures went back up, the water pipes began gushing water everywhere. And I remember if you recall, people were like displaced from their homes and had to move to hotels. It was a disaster. And yet the folks who lived in Whisper Valley were fine. And so this is a really important resiliency story about how, you know, with these kinds of systems and they did have solar and backup to be able to electrify the heat pumps. This community was able to survive a really bad storm or temperature freeze. All right, so now I'm going to put another one that hopefully is similar to something that you all want to do. So this is St. Paul, Minnesota, and I'm showing this one for two reasons. One, this just was announced in March, and it's also really cold in Minnesota. So to give you a sense, Texas was really hot. Here it's really cold. It works north and south. And here, what the St. Paul, Minnesota's public school, what happens is that they have a regular spending capital plan. And so when they're going to do school renovations, they, a year ago, so this isn't even for these projects here that just got money, but they were saying, okay, we have a climate action plan that says that we have to decrease our emissions by 45% by 2030. So what are our options? And so the efficiency of this technology, plus the federal incentives, because right now there's an intense investor tax credit up to 30 to 50% investor tax credit. So between that financial tax credit and the technology, that convinced the leaders of the school district to install thermal networks for their schools. And so they've already built one and they love it. And this grant here is to build 2 additional schools. So this is definitely something that you all could do. Again, it's not utility, but you could start with the big buildings that could reduce emissions significantly. All right, and now I'm going to show a third one, which is a utility pilot. This is in Framingham, Massachusetts, not far from me. It's the first utility pilot in the nation. It went live 2 weeks ago. It was very exciting. It's in an environmental justice community, 37 buildings with 140 customers, and they converted gas, oil, and resistance heat. It wasn't just the gas customers. It was a mixed use, so offices and businesses, they even have like a Gulf gas station, which I find really interesting. And then the cost of installation is being spread across all ratepayers and across time, making it very affordable. So the customers on this loop are paying a flat monthly fee, which is pretty reasonable. I think for residential, it's $10 a month. For commercial, it's $20. And you can see on the map, it's a 1-mile loop around the neighborhood. And then they gave everyone access. So they knocked on every door and anybody who wanted to could be part of it, including a big, I think it's like over 90 affordable housing customers. So that has been a big success here. So it is not just Eversource in Massachusetts that's interested. Utilities across the country are interested. Here you can see the ones in green, Massachusetts, New York, and Minnesota have all filed pilot proposals with their utilities. But there's also a utility network geothermal collaborative that is a group of, right now, it's a fast growing list of utility companies, gas and electric, and it currently has 28. And they're exploring thermal networks as an option for evolving. You see that California is not on here, but I have it. I've been told that PG&E is interested in joining, so hopefully that'll be happening soon. All right, so one of the things that's important is that for us to be able to do this, you all can do this. Communities can do this, universities, schools, private property folks can do it. Gas companies are not allowed to install thermal systems. They're only allowed to sell gas. So one really important piece of this puzzle is we have to pass legislation to allow and incentivize. Amazingly, the first bill passed in Massachusetts in 2021, that is only 3 years ago. When I started this map would have been blank. There would have been nothing. And now there are 7 states that either mandate or allow utilities to install thermal networks. And you can tell that 3 of those states, this is all in chronological order, this list on the right, Washington, Maryland, Vermont, in the last 2 months, passed legislation. So all of those states in orange have passed. And Minnesota passed it in 2021. And then this cycle went around and passed 7 more thermal energy network pieces of legislation. So they're really committed. California, you can see, is in green, and that's because they have filed legislation. So let me just get there. There is a bill currently in the legislature. It's SB 1221. And this bill basically allows regulators and utilities to consider zero emission alternatives for pipe replacement. So when pipes are being replaced, they can look at other options. And this would allow for what we were talking about before, neighborhood scale and thermal networks. It also ensures utility planning safeguards, and that's just going to, making sure that affordability is considered, that environmental justice neighborhoods are being considered, that there's a preference for prevailing wages when they're authorizing spending. So just putting in some guardrails so that when the utilities are doing this, it also benefits the whole system. And this is, and it's scheduled to be heard in July. So this is an opportunity for all of you, if you know your legislators, to just let them know that you are supportive of this bill. That would be really great. And then this is already actually happening in California, PG&E, which is in Northern California. Now, they're not doing thermal networks, but they are doing neighborhood scale. And PG&E has done over 100 projects. This picture on the right is a really great illustration of it. You see that red line? That is a pipe that was scheduled for replacement because it's a leaky pipe. It would have cost PG&E $1.2 million to replace it. There are only 2 buildings on that pipe receiving gas right now. And so by electrifying those 2 buildings for $156,000, they are saving ratepayers $1 million. And so this is the kind of thing that we and you all should be encouraging to happen everywhere. So that is everything that I have. There's a whole paper on neighborhood scale if you want to learn more. Websites for both BDC and HEAT, and happy to answer questions on anything that you all want.
Thank you, Anya. That was amazing. You really covered quite a lot of ground there. We have one question so far from our audience. Eric Pearson asks, if you have an isolated group of homes with no commercial buildings, would it still make sense to create a thermal energy network?
So it is ideal to have homes that have diverse loads and use energy at different times. So it really depends on when, if the homes are using energy at different times, then you probably can still share energy. It's still going to be more efficient than any other system to do that. The Whisper Valley project that I showed in Texas, those are all the same homes. And so they still feel that it's worth it because people use energy at different times of the day and in different ways. And so they still have some sharing, but definitely mixed use, sort of a higher density mixed use is going to make it financially a better proposition, and it'll be more efficient.
And I think you could also highlight the fact that now, of course, this doesn't necessarily mean that you need all these 4 wells to be networked, but the fact that it's owned by a utility has the advantage for the customer that the cost can be spread out over all the customers over a longer period of time, as opposed to each owner having to do it themselves.
I was at a conference this morning with the manager of that Eversource project here. And what he was saying is, okay, he's built this 1 mile loop. If he added another mile loop, the cost would be half, because all of the infrastructure costs can be shared, like that, the pumping station, there's things that can now be shared. So the bigger the system is, the lower the costs for everyone. And that's, again, one of the benefits of doing this at utility scale.
Great. So I'm just going to ask a few more questions, and Kaylee, I'm going to count on you to cut me off before we run out of time.
Yeah, Matt, just real fast. We do have a hand raised.
Oh,
so Philip, I can unmute you here if you would like to ask your question.
Yes, hi. I appreciate the opportunity to be a part of this. Thank you very much. I really appreciate all the information. One of the problems with renewable energy has been that the sun only shines part of the day, the wind only blows part of the day or night, and so in other words, like you have to have a battery to store. And when you were talking about being able to store the energy that would otherwise be blown out of the building with the air cooling tower, it just made me wonder if there's like a storage capacity here where you could store, wind energy or solar energy, for use during the off time. And yeah, I guess that's my question. Thank you.
So that is a very astute. Yes, we in this system we are absolutely using the Earth as a battery, and as you said, it's 24/7. There's no intermittency. I mean, the temperature of the Earth is always going to be the same, and you can store. And I believe in Texas they are trying to figure out a way to store some of the wind energy in boreholes, which is cool. And then another thing that's really interesting is that in Colorado Mesa in Colorado, they can help the electric side by storing more energy in the boreholes when they know they're going to need energy and then releasing it so that then the Xcel Energy, the electric company, doesn't have to buy electricity because they're getting this from the system at Colorado Mesa University. So this allows sort of a demand response capability that would allow us to flatten the electric grid because of that storage capability of the Earth.
Thank you.
Okay, let me bring up my questions again. Okay, so let's say that we were interested in convincing Southwest Gas to make this switch. How would we go about finding out about gas leaks and also how they're planning on upgrading their existing distribution lines?
Oh, such a good question. So in Massachusetts, we forced them through legislation to have to report where their leaks were and what they were going to have to change. We did that in like 2014 because we have a really long, because the history of pipes here is really long. I think that there are not many states who force their states to do that. So if I were to try to convince Southwest Gas, I think if you all have climate emissions mandates and they have to meet those mandates, this is an incredible opportunity for them to explore an alternate business model for how to decarbonize. There's a risk for all of these utility companies that they're not going to be allowed to transition using renewable natural gas or hydrogen or any other kind of fuel. And so they have a huge risk as people electrify. And so this is actually a pathway for them that would allow them to continue with an existing business model, just using renewable energy instead of gas. So I think I would go the route of maybe through your commission, through the California Public Utility Commission is probably the best way to put pressure on the gas utilities.
Great, thank you. So let's say, I'm sure that heat, for instance, is doing a good job of instrumenting this new thermal network, or at least having the gas utility collect data. So let's say that we did some sort of project here locally in Truckee, say, for instance, at the school district. What kind of data would you recommend that we collect as a way to sort of determine, how effective the system is? What kind of things should we be looking for and measuring?
Yeah, so that's such a good question. So yeah, so just a little background. HEAT, the nonprofit in Massachusetts that came up with this idea, has a grant to work with national labs to measure everything about these pilots. And so when you're asking me what they're measuring, they are measuring the performance, the design, the temperature of the loop, the speed, the flow rate of the water, how fast is the water going? Does that change the energy transfer? They've instrumented boreholes so they can tell the temperature of the boreholes. They are looking at cost before and after. They're looking at customer satisfaction. They're looking at everything. And they are trying to get the utilities to do that. When you're thinking of depending on what you're thinking, like if you wanted to do it for a school, I think what you'd probably want to do is understand what other schools have done. And they are tracking different metrics. They are definitely trying to figure out, like, okay, what are the energy savings and the greenhouse gas emissions and the water savings and the costs, of course. If you wanted to compare yourself to a utility model, then you would probably have to instrument what you're doing. And then that gets a little more complicated and expensive.
Great. And so for thermal networks implemented by gas utilities, what sort of regulations must be put in place in order for them to transition to thermal networks?
Oh gosh, we are right in the middle of trying to do that here. So the regulations there's so many aspects to the regulations, but there's the technology. And so one of the things that I talked about several times, the design really matters. And so when we're thinking about utility scale, we want to make sure that we have a design that can expand over time and that can interconnect. So you can imagine a world, let's say in Truckee, where there are you grab some schools and maybe your city hall and maybe your main street does this without the utility, and you install these systems. You would want those systems to be able to connect to the utility system, right? To what the utility is doing, because then it's going to be more efficient and more cost effective over time. And for us to get there, it's like designing the rules of the road. It's like coming up with like green lights mean go and red lights mean stop. And like you want to drive on the right, not on the left. Like we have to, as states are considering this, they have to create what are the rules that we're going to set up so that we can expand over time and so that we can interconnect, so we can do this affordably. So affordability is probably the biggest issue that utilities are dealing with their commissions in New York, Massachusetts, and Minnesota, because we're trying to figure out how do we do this in a way that is as affordably as possible. And so that means system design really matters in terms of cost. And that's why learning from what's happening with the existing pilots matters. You can imagine, for example, some places put a liquid called glycol into the water in the pipe that's circulating, and the glycol is like an antifreeze so that it doesn't freeze. But the one in Colorado Mesa, and there's some in Canada that don't use glycol. Because they're under the freezing line, they don't need to use it. And glycol is a huge cost. And so like even coming up with the decision, do we want to, like, what's our risk to cost profile? That kind of thing has to get worked out. So anyway, so there's the technology. Then there's the customer protections. So you want to make sure that the customers are going to be protected with these systems. So at a utility scale, that's something that they're used to. They're used to making sure there's customer protections. If we end up doing these, that anybody can build these, then we have to think about, should we put in customer protections if other people install these? And in Vermont, a bill that passed 2 weeks ago basically said anybody, any like nonprofit, co-op, any municipality can install thermal networks, and then the commission will regulate them. Will regulate the nonprofit or the municipality or anywhere, so they can rate base the costs over time. And so it allows them to rate base, but it also will put in some customer protections.
Perfect, thank you. So let's say that we have a private, or let's just say a non-utility thermal network. What codes or regulations should that developer be aware of?
Well, it's sort of going to depend. Like if you're in your private property, if you're on a university campus, you have a lot more leeway than if you are going down the middle of the street. So if you're going down the middle of the street, you're going to have to work with your city on this stuff. And I think in California, you all do, these are closed loop systems, so that water is not going to be mixing with any water underground. But I know in California, you guys are very careful about your water. So you're probably going to have to figure that out. Making sure, like, what are the requirements that you have to meet in terms of your drilling, where you can drill. I mean, the rest of it is sort of like here in Massachusetts, schools do this like there's several schools that have installed these, and there's really nothing that's stopping folks who actually own the property. It's when you get into the public property that you're going to have a little bit of problem, or you're going to have to coordinate with your city and your state.
Got it. All right, I have one last question, and I think we're probably going to run out of time here, so that works out. So what money is available from the Inflation Reduction Act for financing these networks?
So the investor tax, well, so the investor tax credit is a big deal for these infrastructure projects. I think the base is 6%, but if you use prevailing wage and apprenticeship workers, that raises to 30%. And then if you use American-made products, which a lot of these heat pumps and pipes are American-made, that's another 10%. And if you do this in an environmental justice community, it's another 10%. So you can get up to 50% of an investor tax credit. There's also a bunch of dollars for just the ground source heat pumps and heat pumps. So that's going to depend on each state. It's kind of, I don't remember. It's like very much based on your income, but each state has different rules on that. But there's so much money that is being laid out here right now that it is a fantastic time to do this.
Great. Well, thank you, Anya. That was excellent. I'm going to let Deidre take over from here.
Sorry, if we don't mind, we have just 2 questions that have come in through the Q&A function. So I'll just go ahead and read them real quick, and I think we might have time to get through them. That's okay?
Sure.
Okay, so first one's from Eric Pearson. You kind of touched on this with the Whisper Valley example, but question is, if you have an isolated group of homes with no commercial buildings, would it still make sense to create a thermal energy network?
Yeah, so that question, I think, was the question that was asked. And I'm going to say yes, depending. It's all about, you have to see what those buildings' energy use is. So, okay. Yeah.
Perfect. That's what I thought. And then what should homeowners in a cold location like Truckee do for backup when the grid goes down?
So this is where if you have solar and a battery, then it's no different than with gas. I mean, like most gas boilers or furnaces right now, they require electricity for the pilot, right? So I think if that goes down, you have an issue. If you had solar and a battery, these heat pumps operate with very little amount of energy. That's why they're efficient. So that would be what you would want to do. And you know, the Whisper Valley case, so most of the houses had that. The electricity did go down for 4 hours in Whisper Valley, like they had no electricity, and yet the temperature of the whole loop remained stable and people's homes were fine.
Awesome, thank you. I think that's all the questions that have come in, so I'll pass it over to you now, Deirdre. Thanks.
Yes. Kayleigh, would you please let everyone know where the recording of this webinar will be available?
Yes, of course. Thank you. So we will upload this recording to YouTube and then send the link directly to all the registrants' inboxes. And then it will live forever on the CTA website. So you'll be able to find it there. We have a drop-down menu that will take you right to the webinar page. So that will live there, but you will all receive a link to the YouTube probably by the end of this week.
Good, thank you. And I just want to remind everyone that this is the first in a series of webinars that we'll be doing. We are hoping to do one a month. We're skipping August. And we will cover the other 2 topics as well as more on thermal energy networks in our future webinars. So thank you so much, Anya. We really appreciate it. And Kayleigh, would you just put up once again the slide with contact information for CTA and Citizens Climate Lobby and 100% Renewable Truckee? Okay, please feel free to contact any of our organizations. We're happy to speak with you. We're happy to have your input. We're happy to have your participation. So thank you all very much.